STEM in 7, and today we're going to be talking about the formal definition of a derivative. So let's start off with the question, what is a derivative? Well, a derivative is essentially the slope formula of an equation. So in other words, if you have an equation, f of x, and you want to find the slope at point C, you can use the derivative written as f prime of x and find the value of f prime of c. Now this is going to give you the slope at point C on f of x. Now, how do you find a derivative? There are multiple methods to do this, but for the formal definition of a derivative, let's keep it simple. As I mentioned before, the derivative is the slope equation for the parent function. So, we all know y2 minus y1 over x2 minus x1 is the equation to find slope. Now here's the dilemma. We want to find the slope at a certain point. We only have that one singular point. But you can clearly see in this equation that we need 2 points to make this equation work. So how can we modify this equation to work with only 1 point? Well, let's look at a quick graph. If we want to find the slope at, let's say, point C, we don't have any way of using y2 minus y1 over x2 minus x1 because we only have our singular point. So if we want to try and take another point, let's say we have a point here and maybe a point up here. And the distance from point C to our point here is h, and our point C to our blue point up here, let's say h1. Now we want h to be, we need h to be as small as possible. We need h to be as small as possible. We want the point to be as close to C as we can get it for our slope to be the most accurate. So, as h approaches 0, as h decreases, our accuracy increases. So, I don't know about you guys, but that sounds to me like we are going to be using limits. So, the limit as h approaches 0 is going to give us that slope at point C, that derivative that we want. So the most important thing to remember here is not to overcomplicate things. What we're going to write next is just going to be a variation of the slope formula, right? y2 minus y1 over x2 minus x1. If we're going to try to rewrite this to serve our purpose, let's start with y1, right? So if we've got f of x as our equation, we can just put that right on in for x1, right? That's just our first point right here, f of x, right? So what is our x1 going to be if we're just going to use f of x, keeping things simple? Right, it's just going to be what's inside here. It's going to be x. Now, over here for y2, right, we need to think about this a little bit more carefully. So look down at the graph in the corner. We've got our f, right? But what's our next point going to be? It's going to be x plus h, because that's what's going to make this point different from f of x, is the distance, right? So f of x plus the distance from the desired point, h, right? So same thing at the bottom, whatever's plugged in up here, you write that down below. Now, we can simplify this down just a bit. There's nothing we can really do at the top here, so we just got to rewrite that. X plus h. Again, this plus h is showing that it's a different point. Using our algebra, we can take positive x and a negative x, which cancel out. So on the bottom, we've just got an h. So now what we've got here is the simplified, rewritten slope formula, which we can use just with 1 point. This right here is going to be very, very important, so make sure to remember, write it down somewhere, because this is the template for the formal definition of a derivative. Alright, so let's move on to trying to solve it with some more equations. Again, up here we've got the formal definition of a derivative template. So let's try using a equation. Let's say that f of x is x squared. Right, so just write down here, limit as h approaches 0. One note is if you guys are planning on taking the AP test for any AP math class, AP Calc AB, BC, AP Stat, you are going to have to be writing this limit for every single step because the AP readers will be looking for it, especially on those free response questions. So, we're going to start off, it's just easier. We divide that everything by h because nothing there is going to change. Subtract f of x, which we know here is x squared. And then we put in x plus h for x. So we've got x plus h, right? And we're plugging it into the equation x squared. So again, remember, not to overcomplicate any of this. It's just going to be your algebra from here on out, right? So simplify this down. We've got x squared plus 2xh plus h squared minus x squared over h. Again, here, I just simplified that out. And now here, I think there's some simplifying that can be done. So first, that's the first thing I see. We can cancel out those x squared. Plus x squared minus x squared cancels out. The next thing I see is that we've got an h in common with the leftover terms. So it can be rewritten, again, remember to write your limits at the side, as if you take out these h's, 2x, the h is taken out, plus h, no squared because h is taken out, divided by h. Oh, yep, that gets canceled out. So what you're left with, 2x plus h. Because as h approaches 0, don't you think this would just be a 0? So now all you're left with is 2x. So what have you found here? You found the derivative, or the slope equation, of x squared. So if you want to rewrite this, f of x equals x squared, and f prime of x, or the derivative, which you just found here, is 2x. Now, if you want to find the slope at a specific point, let's say our point is 2, right? The slope on the graph of x squared at point x equals 2 can be found by plugging in 2 into f prime. So 2 times 2, 4. The slope at f of 2 equals f prime of 2 equals 4. That's basically what we're finding here. Now, if you want some more proof of this, and go on to the next slide, we can do it the long way. We can. So limit, we're just going to go through this pretty quickly. Limit as h approaches 0. We've got our equation. We can just write out really quickly. That's our little template that we've been using this whole time, right? Remember? But we're going to plug in x equals 2 like we did on the previous slide. So limit, again, remember to write those limits on the AP test. Limit as h approaches 0, f of 2 plus h minus f of 2 over h. Now we know that our equation is x squared, so we can take that 2 plus h squared minus 2 squared over h. So, simplify that down. Again, writing that limit. It's a bit of a hassle. Not going to let you guys forget it, though. We're going to use our algebra. We're going to expand this out, so it's h squared plus 4h plus 4 minus 2 squared is 4 over h. This right here, just like those x's on the previous slide, these cancel out, plus 4 minus 4. Now, limit as h approaches 0. Again, we can take that h out, divide it by h, and that cancels out one more time. Now, limit as h approaches 0 is h plus 4. So if we plug in 0 for h, we are left with 4, just like right here. Notice how we got the same answer, but we kind of just took out this whole extra step of plugging in that 2. So yes, just as a summary, this is the formal definition of a derivative. Use this equation as a sort of template. And just one more time, remember that everything ties back to this key concept that the derivative gives you the slope at a certain point on f of x. So again, remember these 2 things, and derivatives will be so much more simple.